Let's continue with the program. The last person entering. Well, most people here love automation. Can we get some hands who love automation? Yeah. Okay, Chris, you don't love automation? You just talked about it?
I love automation.
Okay, great. Arnoud, the stage is yours to tell us about well, how to do automation correctly.
All right, well, correctly, how to do automation. There's always things to improve. I'll start. This talk is about automating your infrastructure. I used to work at Tumblr. I now work at LeaseWeb. But I'm curious, how many of you are still running your own infrastructure versus cloud? Wow, I did not expect that. Okay, well, great. This talk will be very relevant for you. So let's dive into it. So the problem is deploying new servers is very repetitive, it's slow, it's error prone, and we don't like that. We like, so this is a job we don't want, being in the data center, typing in stuff, debugging, being in front of a warm owl or a cold owl, it doesn't matter, it all sucks and makes loud noise. So, the job I also don't want is when you get a whole bunch of new servers, unpacking them and racking them. But what I do want is production. So I want to get as fast as possible from boxes to production. So how do I do that? With a lot of automation. Wow, there was a fancy animation in there that I didn't put in there. Sweet. So why would we use automation? So there's a couple of reasons to use automation, which are listed here. But for me, it's a stupid repetitive task that I don't want to do. So that's my main focus for automation. And because I don't want to do it, I actually speed up the process and have less errors, which is great. So, to give you a bit of a scope of the problem I'm dealing with on a daily basis, at LeaseWeb we currently have 14 data centers, and 7 in the US. We have about 70,000 servers, which are all multi-vendor, so we have HP, Dell, IBM, Supermicro, Huawei. We have, everything we do is multi-vendor, so we have 3,000 switches of Juniper, HP, Arista, Cisco, basically a lot of vendors. And we have 3,000 power bars. The Schleifenbauers are finally going away. They're horrible if you ever worked with them. They're so bad. Anyway, I have a lot of things to automate, and I have a lot of systems to do it on. So I'm going to show you a list of things I would like to automate. So I want to start, of course, when you deploy a server, you have to do all these things. Maybe you skip some of them, maybe they're not too important for you, but this is basically for the LeaseWeb and for Tumblr, these were the things we wanted to automate. And most of these things that are already checked, people know how to do, right? Automatically installing an OS, kickstart, whatever you want to do, or a golden image, or applying whatever. Configure OS, apply Chef, Puppet, Ansible, whatever automation tool you use to install software, to configure the software, and adding to DNS is talking to Power DNS or Bind. Those are not the harder things to do. But so I'm going to go over not the things that are already checked because they're pretty easy, but the things that are unchecked and most people do not automate. So to give you an example, this is tested on a range of this hardware, and we have multiple thousands of models of these servers, and new models are actually getting added. Basically, once every month there's a new model that we add. To give you an idea of a life cycle of a server, I think you pretty much know this, but it's nice to make a diagram of it. So a new server comes into the data center, and it's getting prepared for use. So that's setting up the BIOS, making sure it's in the rack, making sure it's labeled, making sure it's connected. configure the latest firmware, things like that. And then once that is done, it's ready in stock, and we try to keep the stock as low as possible because that's basically wasted money. So everything is just-in-time delivery. When a customer says, I want this server, we basically generate the config, which could be installation, an image, or whatever the customer wants. And then the server goes into maintenance. When it breaks, it goes back to the warehouse, they fix it, or we replace it with a new one. And that's the maintenance. And then after an X amount of years, we deprecate the hardware, throw it on Pell, and recycle it. But before you can start all of this, basically the first thing, the really most important thing is you need to have one single point of truth about your hardware. This is where I see a lot of companies failing. The information about systems from Windows are in the ADDNS server. The Linux systems are in the rack tables or some other solution. Some have Excel sheets with some sort of information. So for me, it always starts with a good inventory. And if you don't have a good inventory system yet, go take a look at Collins. Collins was built by Tumblr, and it's an open source. Yeah, question.
How do you spell Collins?
Collins, like Phil Collins.
Okay.
It's actually named after Phil Collins. That's a whole different story, though. In any case, I've made it abstract, but if you're looking for an open source inventory, then take a look at Collins. But it holds basically all the information about the device, all the important information, so host name, hardware details, network details, power details, IPMI information, credentials, everything that you want to store about that server should be in one single inventory. But how do you get the data into the inventory? So, question, how do you currently get your data into an inventory?
Export resources.
Good, you're one step ahead. Well, the most people has answered is just import the data supplied by HP or Dell because they don't make mistakes. No. So I really don't want to do manual intake. I want to do automated intake. So there's a couple solutions to do intake. And what I mean with intake is basically you get a box, you put it in a rack, and then you figure out where it is, what it is, how fast it is, etc. And I usually do this with a live CD. So I do a Pixie boot. I'll show you in a minute. Here's two examples of software that do this. This is my personal one, and that I used for Blundell. And this is the Tumblr version. We also have a version for Lifecycle, but it's not open sourced. But basically, it's a live CD Linux image that we boot, and it has some sort of tools. And I'll go over the tools, the most important tools here. Are you familiar with LSW? LSHW? It basically reads all the sensors of the computer and gives you the output. I have this motherboard, this serial number, this many drives, things like that. So this is a great, it gives you a big XML blob, and Collins will just eat it and make it into nice, readable human information. Or you could eat the XML yourself if you wanted to. So LS Hardware will give me an overview of all the things that are running in, all the things that box has. Who knows LLDP? Link Layer Discovery Protocol. Only 1, 2, 3, 4. Okay, some people. Okay, so the next problem you have is, okay, I now know what my box looks like, but I don't know how it's connected. So one of the things you can do is enable LLDP in your switch. Most of the switches will actually support this, and it will totally report back hey, I'm connected to an EX3300 Juniper switch on port 9. So you don't have to trace the connections anymore, but it's just simple as running LLDP. It's a super simple protocol where the switch tells you on which port you are on a regular interval, and the daemon on the server just listens to it. But you can also do it the other way around, where the server advertises to the switch, hey, I'm server ID blah, and I'm connected on port 9. Or you're connected on ETH0. You can do it that way too. So, okay. So we know the hardware, we know how it's connected on the network. Now we need to know how it's connected to the power, and it really sucks. There is no protocol for discovering how power is connected. So I wish there was. Well, this is really vague, but it's a picture of a power bar. How many of you have power bars in the data center? Yep. So this is the thing we came up with. Every item in our rack has a QR code. The QR code is for the power port. There's a QR code on the server. There's a QR code on the top of the rack, which specifies the rack. And there's a QR code, I don't think you can see it. Oh yeah. There's a QR code for the U height. So you can basically, the way we did server deliveries at Tumblr is we would buy an entire row of racks, so 10 racks. And Dell has an automation center, and we would specify a rack layout, and they would ship the entire rack completely assembled, cabled. The only thing we would have to do is plug in the power, plug in the uplinks, and basically turn on the rack. As soon as the rack came online, it would do a pixie boot of the intake. It would scan all the hardware, and it would report that to Collins. And then a person in the data center, and we'd actually, if it was done with intake, it would start blinking blue LED at the front. And a person in the data center knew, oh, I can actually scan these servers now. They had a QR code scanner basically attached to the laptop. They would scan the asset of the server, and Collins would say, oh, I don't know this asset yet. Scan the rack, okay, scan the rack. Scan the U position, okay, scan the U position. Scan the power port, and basically that's your physical intake done. Those are some things that, well, the rack position you could probably take away from the switch if you label the switch accordingly, but it's easier. Just if you have to do power intake manually, you might as well intake the rack manually. So this is basically the process we came up with intaking mass amounts of data of servers. To go back to the things to automate, we basically covered the inventory. I did not cover configuring PDUs. We had the PDU slide. To go back to cover configuring PDUs, it really sucks. There's no way to automatically provision PDU. You put in a serial console, you write a Ruby script to talk over the serial console, you give it an IP address, and then you walk away crying. I can't stress enough how much I hate these things. As soon as I get permission, I want to get rid of all the power bars and just use IPMI rebooting. It's so much nicer. Okay, so next item on the list. I want to automate firmware. Firmware updates. Before it was really hard. There was you could only reboot. You could only do some maintenance on servers if you could reboot the server. And basically, we have a challenge when a server is actually in use by a customer. We can't touch it anymore. So the only way we can do firmware updates is when the server is not being used. Okay, so it can take years of use before we can actually go back and reset the server, update the firmware, or it can take a month or a week, however long the server is not in use. So what we do, and it kind of hurts me, but all the providers that firmware are just binary blobs. You get them from the firmware providers. There's a bunch of tools. Dell has DSU firmware update. HP has nightmares. So each provider has their own method, and we basically bash script around their shell scripts. Or Dell now has a Lifecycle controller manager, which is actually relatively okay, but I want to use it in an automated fashion. So basically I come down to back into my intake image and run the provided tools by the provider and just hope that it all works. It's pretty bad. Okay, so setting BIOS settings. How many of you configure the BIOS? How many of you do it manually? Okay. There are some tools. Actually, this is pretty reasonable. HPO and CFG for HP, ACU for IBM, syscfg for Dell, and actually Dell has like 3 utilities to do the same thing but slightly different, and not all do the same tool. It's special. Anyway, here's an example for how you would configure a Dell. So I use syscfg and I set the COM port redirection for if you want to do serial over LOM. So it's IPMI. I set the console speed and I enable IPMI. So this is configuring the BIOS. But next I want to be able to use the IPMI interface, so I have to automatically configure the IPMI interface. So I use IPMI tool to configure IPMI interface. So how many of you use IPMI? Okay. Basically, it's pretty easy. IPMI tool works on pretty much every model, but there are some exceptions. So. Luckily, there is a better horizon. I don't know how, but all the hardware vendors agreed upon a standard which is called Redfish, which is basically an API endpoint for doing everything you now do in DOC or ILO or whatever vendor called. This is rolling out to the first Dells and the first HPs right now. I think the blade chassis from Dell just were released with the Redfish firmware, and it's really nice. You get an HTTPS endpoint to just reboot a server. So you just say reboot, and there's an authentication method, or there's all kinds of things. Oh, and it includes IPMI via web interface without Java. It's HTML5, no plugins required, so that's finally. All right, so that on the BIOS and IPMI. The next up is RAID partitioning. How many of you do RAID partitioning automatically? Okay. So how many of you know Mega CLI, the tool? Yeah?
Unfortunately.
So it's pretty, so we, at least we also have a CDN, and CDN is an even more repetitive task because we basically have 3 types of hardware profiles. You have a load balancer, you have an edge server, and you have a storage server, and those just repeat in racks and racks and racks at the same time. They all have RAID partitions. So basically what you see is the first line is I set up a RAID 1 partition for the OS on disk 24 and 25, and then a RAID 6 over the rest of the drives, and then add 2 hot spares to the RAID 6. That's basically all this is doing. So okay, and you can make basically you can script any RAID partition. We have RAID 1, RAID 10, RAID 5, RAID 6. It's pretty easy. So Mega CLI for that. Now, the frustrating thing for customers is when you give them a brand new box and they break after 2 weeks. So one thing we want to make sure is when we deliver hardware to customers, it's actually tested and battle proven. So what we did, there's an open source tool called Breakin, and it's made by Advanced Clustering. They don't ship this software, it's part of their ISO. It's really not that hard to extract it from their ISO and just make an RPM out of it and ship it. And we actually, at Tumblr, we did that, and we provided the RPM and the spec files back to them, and they were refused to basically publish it. Interesting. It is open source, however, so we can use it. And I don't think Breakin will be very known here. Anybody know Breakin? Basically, so it is performance testing and breaking in your new device. So it will write random files to your disk at maximum speed. It will write a shit ton of memory tests. It will basically test every part in your server for an X amount of period of time, and if it fails, it will exit and it will leave a report of what actually failed. And if it, you could set it for, we did new clusters on for a week, full blasting at full speed to see which nodes actually were broken. And I think with this, we were able to get, I would say 80% of the failures that would happen otherwise after like a week or two. I mean, nodes randomly fail after that, but most of the newly provisioned nodes we could easily pick out with just Breakin. So that's a nice thing to look at if you have to provision a lot of hardware. Okay, so going back to things we want to automate, we have updated the BIOS, we have configured the, we have updated the firmware, configured the BIOS, configured the RAID, set up the BMC, that's the IPMI interface. We've stress tested the hardware. Now let's go back to how we figure out what new hardware is. So who's familiar with iPXE? Okay, some people. So iPXE is basically Pixie, but then smarter. So you chain load Pixie, you kickstart via Pixie, and then you chain load a file, and it gives you iPXE. And iPXE allows you to do HTTP requests instead of TFTP, or HTTPS request, or a little bit of scripting. So what we'll do is basically we'll Pixie boot the server, we'll chain load iPXE, and then we'll make a little script that says get the MAC address of the first NIC, and we'll post that to a Collins server or our inventory, and we'll ask the question, hey, do you know this MAC address? And if it's a new server, the answer will be no, I do not. And then we'll say, okay, well, since we don't know you, here's the intake image, go chain load that and report back to me when you're done intaking. So it will reboot, or it will do intake, it will report the hardware back to Collins or whatever asset database you have, and once that is done, it will reboot and start over again, and after the intake, it will actually know the MAC address so you can give commands to it. So let's say we did the intake, all the hardware, BIOS, IPMI settings are correct. Basically now your server is ready for inventory. So you can give a command to it. You could give the command start provisioning Linux, Windows, whatever you want, or you could give the command power off because you're not requested at the moment. So we'll go back to the inventory. So the second question you're asking yourself, do I need to provision this machine, or is it already provisioned? If there's no installation task, no, try to boot from drive or power down, whatever the command is, or otherwise start provisioning. Is it clear, the flow diagram? Okay. So this is a little bit of future on what we're currently working on at LeaseWeb. So we want to basically support every OS that the customer asks for. We have to pick some support, so but we support the major Linuxes. FreeBSD is not on here, but you can install it. OpenBSD is on there. No, OpenBSD is not. But we install CentOS, Ubuntu, Windows. Basically, we don't really care. So the thing we want to achieve at LeaseWeb is we want to be able to do server deliveries within 15 minutes. And I don't know if you ever did an automated installation of CentOS or Linux or FreeBSD. Oh, FreeBSD is very fast. But you won't get there in 15 minutes. And that's including setting the BIOS settings, updating the firmware, things like that. So, so what we actually do is we have a continuous integration, or we're working on continuous integration build that basically does an installation of Ubuntu or CentOS to a destination directory. We tar that, we verify that actually everything is correct. We remove sensitive data like SSH keys and things like that. We make a tar of that, we put that on our internal mirrors, and then we have a build script which basically partitions your machine, downloads the tar, and while it's downloading the tar, it's unpacking and installing it onto your OS. And we have successfully been able to install CentOS and Ubuntu in less than 2 minutes. So that's a nice improvement. So that's what we're currently working on, to give you an example. But everything we're doing is basically automating away all the things that you normally would have to do. And to go one step further than just telling you how to automate all this infrastructure is taking it completely away. So we want to basically provide all the features that you would normally have, but then via an API. Oh, this URL totally falls off. So we have APIs for everything we do, and we publish them. So as you want to use our infrastructure, there's actually API documentation on developer.leaseweb.com, and there's an example on how to pixie boot basically any image you want onto our infrastructure. So if you want to do a pfSense installation, we currently don't support that, but if you have an ISO, you can pixie boot and you can just tell it, load this OS over IPMI. You can go to the machine and you do the installation yourself, or you script it, or you do automated installation. So that's that. Okay. Any questions about that? I can probably give a demo if I think we're running. We have a lot of time left on messing around with our API, which is pretty fun. And one thing that I would like to mention is this is a pattern that you see a lot in our infrastructure because we have 17 POPs at the moment. What you'll see is that we have a local executor, for example, in Amsterdam, San Francisco, Frankfurt, and then we have a service engine in Amsterdam or in a central location. This is basically how we make sure we only have local networks in each POP, so there's no interconnection between the local networks. This pattern allows us to basically have a central location where the API can talk to, but still deploy and do actions in each POP. There's still a central point of failure in Amsterdam, which we obviously want to get rid of, but we can work around that. And this is actually another thing we want to improve. So currently we have a lot of Juniper switches, HP switches, all of them you can't really do anything with. The way you automatically provision is you either make a config file automatically and it PXE boots, and then it boots that, and that's the only moment you have for provisioning. And if you want to make a change to a switch, you have to log into it individually or buy a big appliance thing that I don't want to do. So, how many of you are familiar with Cumulus Linux or Linux on switches? Okay, so there's now a vendor called Cumulus Linux. And basically what they do is they switch the hardware from just being hardware, and they can run Linux on top of all the vendors they support. So Dell is actually a vendor, Acton, there's Edge Core, we have, let's see. Okay, so to give you an example, Dell, Edge Core, HP, Penguin, CPT, Edge Core, Supermicro even. So the great thing about these things is, there's a Dell one, is we finally get rid of the notion of a switch comes with a vendor OS. Alright, a switch comes with a vendor OS. Currently, that's you buy a Juniper because you get Junos and you get the features you need. This allows you to buy hardware from any vendor. There's now a bootloader on the switch called ONI, and you can basically say, I want this OS. There's multiple OSs. Actually, Dell has its own OS called OS 10 or something like that. Dell OS 10. There's Big Switch. There's a couple other vendors that you can run. I just run Cumulus Linux on these switches. It's basically a Debian flavor. It does have a license, but it's not that bad. And then basically you get a switch with 48 network ports that you can throw in a bridge, and you can run Chef on it. And finally, I can automate my network stack. So that's another thing I'm currently working on. Did you know about this existing? Okay, well, good. All right, I think back to my slides. So, network automation. I just want to mention, if you like technology talks like we have here, Lisa is also having a tech summit next week, which is not about Lisa at all. It's really cool speakers. I don't know if you saw the posters, but we have speakers from Google, SoundCloud, and multiple other big companies. 1Password, the security girl from 1Password is coming. It's pretty awesome. There's a fee of 25 euros to enter, but there's free codes right there. First come, first serve. And if you use the code NLUUG, then it's for half price. So, yes.
But you are free to share it on Twitter, of course.
Yeah, I don't care. It's great.
And we want to be trending today. We already were that a few times, so add the NLUUG tag to it, and we will be trending again.
Okay, great. So that's basically most of my talk. If you have any questions, feel free to ask them. Is there any particular thing you really frustrates you that you would like to automate? I can share how we do it, or not.
Why don't you use blades? Just cost?
Because of, you would normally use blades when you're space constrained, or not.
You lose your dependency on your power bars, you get best class infrastructure.
I can lose the dependency on the power bars, but just not building power bars. I mean, every unit currently has IPMI, so it's really more of a, I need to convince Lisa that IPMI will not fail in 99.9% of the cases, so it's really cost-effective, more cost-effective to get rid of these power bars than to have them.
Isn't that good? Last time I did IPMI many years ago was
It's rock solid, unless you have shitty vendors, but most of it. HP and Dell, it's pretty rock solid. Supermicro is okay.
In Dutch or in English? Question?
Yeah?
If you want to lose the power bars, I think it is a requirement that you don't have the requirement to measure power consumption.
Per server, you mean?
Yes.
Yeah, so we don't measure per server. The only thing we measure is per rack. That we don't go over the quota, that the distribution units don't get overloaded, things like that. And we can measure that from the tap units that are actually on the bus rail. So we can easily drop the power bars.
There.
Small question on one of the earlier slides. you had this flowchart, and you told us that whenever there was a problem with the physical server, it would go to maintenance. But do you do any checks while it's mounted in the racks, or do you just remove it first, put it back later on?
Oh no, if it's an easy fix, we fix it in a rack, but if it's actually, so if it's sold to a customer, we'll do everything to keep the server where it's at. But if we have to remove the motherboard to replace it with a new one, we actually take it to the tech area and take care of it there. There are some customers who say, I don't have stateful data on this server, I don't really care about this server. They power it off, they put it in maintenance mode, and they say, give me a new server.
Yeah, okay.
And that's fine with us.
Do you have an automated workflow to find memory errors, etc., or?
We actually do. So every time, for example, every time we do a reboot, and if we haven't done an intake for the server for longer than I think 6 months is I think the period, we force a hardware scan. We don't change any settings, we don't change any firmware, but we do force a hardware scan so that we know that all the changes that have been made to that machine are actually in our inventory are still matching. So if you reboot the server, it will take 2 minutes longer to reboot. Well, guess what? If you have an IBM M4, current reboot time of that machine is 15 minutes.
Yeah, okay. So, and do you use the system event log through IPMI in any way, or?
So the system
the SEL, the system event log, which you can access through IPMI.
We currently don't.
Okay.
Is there any specific reason why you would choose to use the hardware rating controllers instead of software rating?
No.
Just that.
Because because all the dual CPU models that Dell and HP and things like that deliver, by default, come with hardware rate. So I really don't want to. I have no use for them. We can provision everything with software rate, and we actually support that. But in most of the chassis that we built, that we bought in the past 10 years, there's actually hardware rate controllers. So I probably have to do some automation around it anyway. Okay. Do we want to start fucking with our API, or do we have time left? I think so.
Yeah, we have a few minutes left.
Unprepared demos, guys. So, developer. So, for those that don't know, we have pay-as-you-go servers, which is basically an API call to provision of bare metal. So, with bare metal, I mean actually physical machine, no VPS. So, we have a whole API for just provisioning servers. The only downside is we have to have them in stock, so you have to pick a server that we actually have in stock. But let's say you want to, for a pet project, you want to spin up a dedicated server because you need the performance. We could go ahead and play with our API for that. So, if you're not really into the API, you could also provision it via our customer portal. Basically, I now have an account that only works in the US because it's part of our US entity. But basically, it gives you a list of available servers and available configurations. You can say, I want more RAM. And we don't have any. Like I said, I'm only searching through the US now. The Netherlands is by far our biggest deployment. filter on. Really? Okay, I can filter on SATA. I want really cheap machines. No, we believe me, we have really cheap machines. So, do I want private networking? Alright, well, it's very tempting to just press buy, but I wasn't here to actually show you how that worked. I was here because of this feature. Ooh, maybe I can use it. It has to make pictures. Oh, where's my private key? Alright, I really should have prepared this. Alright, I won't be able to get up and speed that easily. Alright, this way. Okay, so I don't have my private key on this laptop, so I can't, unless I start making a new key, which I can. For now, I know I shouldn't do that. Okay, so I have my new public key. And I can put that here. I have my new public key here. I can save it. All right. Start Ruby. Do. So now, oh, one more minute. It's a race against the clock. Here's my password. Yes. All right. So, here you see a list of my servers. And now I have a list of operating systems that I can install on these machines. And here you have an installation call. That's probably a little too long to actually show you. But let's say I want to do my own installation over iPXE. So you have, so I have my server ID. Let's pick a server I'm not using. So bare metal ID there. And then I do. I guess I'm running out of time. So basically what this would do is I would set the DHCP lease to boot from example.com/boot.iPXE. If there was an iPXE file there, it would, and I would have to do a reboot command now. So that's in the API somewhere. So I basically set the IP-my lease. There's an IP-my, there's a DHCP lease saying, hey, chain load iPXE, and then chain load this URL, and this will start your custom installation. There's another command to actually give a reboot to your server, or if you don't want to use iPXE, you can just provision it yourself, or whatever you want to do. So I ran out of time. Sorry.